Hello, welcome to the series of Cat of the Week, FastAPI application. With this video I will start the second part of the series where we will take a look of more advanced concepts which are related to creating an application with Python and FastAPI. In this video I will explain how I will integrate ElasticSearch because there is a performance issue with Firestore when we have, for example, more than 1 or 2,000 cats. Even we can have more, and we have performance issue when we get a cat for vote. We start to see some delay of the response, and in the second part of this video I will explain and show where exactly is this performance issue. And on the third part of this video I will show how ElasticSearch is integrated, and since this is for more advanced users I will show already writing code, and I will just explain what I've changed, and I will show short demo of the better performance when we are using ElasticSearch. Okay. Hello. Welcome to my channel. Today I will talk for more advanced topics, and I will start with the first topic on which I want to give attention. So, as you remember, if you watched my videos which are related to the Cat of the Week FastAPI, you can find the series in my channel. We created a route where we have to select a cat which is for voting. And here I have two queries. One is to select the vote history for the user, and the second query is to filter all not voted cats. Since Firestore, we are using Firestore, let me describe that. We are using Google Cloud Firestore as a database. It's no SQL database, and this database do not provide SQL query language, and we have to query a lot of entities and manipulate them. So we have to filter it in the Python application. In this situation we are using FastAPI, and we have to sort and take one cat, you can see, to limit. This is the limit operation, this is order by operation, and this is where and or query and end queries, if you are familiar with SQL query language. And let me show you the performance issue. Here I will vote for a cat, and you can see we are waiting a lot to vote for a cat. More than 1 second, almost 2 seconds, which is too much in my opinion. Of course we can cache the next image in the front end or something like this, but I think to focus on the back end and how we can fix that performance issue. So here I will show we have 6,000 cats for which we can vote. Imagine if we have more, 10,000 or 100,000, we will have big performance issue. And if you watched my videos, I deployed this application to Google Cloud App Engine, and let's test in this App Engine. You can see it's taking longer. Okay, 7 seconds, almost 8. Okay, now it performed faster. Okay, but still almost 3 seconds, it's too high. But here we just return the same cat. Okay, so let me vote here a few times. I can't take the next cat for voting. And you can see 2 seconds are too much. So we have few options. First is to add more resources as CPU power and memory to the App Engine instance. Second is to use better Firestore, and I will try this definitely, and I will show the result. To have a better Firestore instance, and the third one is to use some third-party service like Redis or ElasticSearch. Definitely, I think I will try with ElasticSearch how we can integrate ElasticSearch in our application. So thank you for the attention. This is some intro for the problem with the performance. Right now, let me show the implementation of the integration with ElasticSearch. First, I gave an index name, which is current round cats, and current round cats mapping. I added the properties which I have from the database model, name, created on birth date, whatever we have there, and voted user IDs. This is the new column which I want to add. And here I created an adapter pattern, my own class with functions which I will use in the application. I have functions for creating index, adding documents, deleting indexes, and for search and replacing. This is important to show. And here I want to say that when we replace a document, I added refresh. This is really important. Let me show what that means. Usually, ElasticSearch have 1 second to re-index the documents, and when we want to add a vote and get a cat which doesn't have vote from the specific user, we can receive the same cat, because the querying can be less than 1 second, and we will receive this same cat. So for that I am adding this refresh param. ElasticSearch refreshes the affected shards to make this operation visible to search. And here I added true to make the refresh. Okay, let me show now the main file. Here I just added a try except statement to create the index if it's not existing with the current round index name and the mapping, and to list all indexes. I will show now, so I will reload. You can see index current round cats exists. Okay, let me go to cat route. So here cat for vote route, where we got the cat from the database. Right now I am getting the cats from ElasticSearch queries. And here what we have a query, really interesting query. We have boolean, and this boolean is must not, which means this ID must not be in voted user IDs. And voted user IDs, I have to mention that it's an array. Usually for this keyword type, we can add strings or list of strings. And here I'm sorting by votes, by ascending order, and I want to take only one. Here I'm taking the response. You can see from the search function which I added in the adapter pattern class, and I'm returning the cat for vote with new module, class module, where I added voted user IDs, list of strings, filled with default factory list. And when I get the cat, here is try accept. If no more cats are for this user, I am just returning message no cat for vote. I'm taking the image, and that's all here. So let me proceed with the next. When we post the cat, and here I'm checking, okay, do I want to do this user tries to vote for the same cat? And here you can see I'm searching for the cat by ID. Here again in the ElasticSearch we have query terms ID by cat. I'm awaiting to search and receiving the response. And if user ID is in this array, I will raise an error. And here what we have, I'm appending the user ID to the list and replacing the document where I said I'm using this refresh parameter, which is equal to true. And then I'm adding the vote if it's like or not. So let me now show you. Okay, so I will open the terminal. Let me refresh. And I will start. You can see the time is not so big. You can see ElasticSearch even became faster. So we are receiving a response for less than 400 milliseconds. Okay. So you would ask me, okay, but what will happen if we have more and more? Let me open. I have a custom script where I wrote Locust load test. Here is the load test. Let me stop this and rerun it, because in production we would have at least 10 workers. Okay, I started 10 workers for this application. Let me now open again Locust. Let me open it again because something's happened. Okay, here is it. And post vote for get minus f. Okay. And open the user interface. I will add 100 users. And I will ramp up these users on every 5 seconds. Okay, let's start the application. So what we have, we are registering 100 users and log in them, and they started to vote. So let me show the code just to clarify. If token, we create the headers, and here we get a cat for vote, and with that cat for vote we are voting. And as you can see, we have a lot of requests, and here the average milliseconds for the response is almost 300 for the cats for vote, and for posting the vote 200. Okay, so I think I have this application here because it's already open, and you can see we have really nice performance with 101 users voting for a cat. You can see we still have really nice performance. I'm pretty sure that if we have a better instance of Elasticsearch, maybe we would receive even better timing, because my instance is almost on 100% loaded. Can see now it's better. Okay, thank you for the attention.